Welcome, welcome all. The name of our course is Perception Algorithm for Autonomous Systems. What is an autonomous system? An autonomous system is one which actually performs its tasks assigned to it autonomously without any human intervention. So, just like an human, it has its own sensor, just like our sensing organ, and human has your eyes, ears, tongue, skin, everything. Similarly, autonomous system has its own sensor systems which helps it to visualize the environment. The environments, then what in case of human does, the environments are being processed normally in a human brain. Autonomous system, same context, the informations are processed inside a computer. When the finally what part, then when the decision is processed, then what action needs to be taken, that is being decided. So, again part of brain, part of computer, in autonomous system it is decided, and finally it comes to the actuation. So, for human our actuation is our hand or leg, what I want to do. If I want to run, if I want to stand still, it can be decided. So, similarly the actuation systems are some kind of electromechanical or electrohydraulic actuators which decides how the autonomous systems, what task it should perform. So, when I distribute the autonomous system, it has total 3 different layers processing. One is called the perception layer. Perception means sensor data processing, that is the topic of ours. There are 2 other layers, one is called planning layers, another one is called the decision or control layer, the actuation layer. So, we in this lecture we will only concentrate on perception, the sensor data processing part. So, sensor data processing, there are 3 major parts into it. We won't talk about the sensor characteristic in detail. So, that is not a part of this lecture. The processing part, since it is a lecture, so it is divided into 3 separate elements. One is called tracking, one is called sensor fusion, multi-sensor data fusion, and third and last part is the target classification. So, whatever sensor measurements I am, what does this tracking means? Tracking means whenever I am giving the sensors data. So, tracking actually keeps track of the object position over a period of time. So, it is used to estimate what is the object location, what is the object velocity and its kinematic feature. So, it is an estimation problem. So, what we will learn first? We will learn what is estimation theory. We will know what is called filtering, especially there will be lot of works on Kalman filter, and then we will know how to do the tracking as a whole. Next part, when the data are incoming from several sensors. So, each sensor has tracked and it has given you tracked output. Now, how optimally I would like to fuse the data or combine the data, so that if one sensor has a deficiency, the second sensor can compensate. So, that part is called, and so that ultimately the decision which your autonomous system is going to take is actually helps. So, that part is called sensor fusion. And classification, you all know, it is a machine learning branch. So, it helps to identify the whatever object my sensors has picked up, what is the type of object it is. So, it is a set of supervised and unsupervised learning or classification algorithms. So, this is a mixed course. So, this is a very practical oriented course, actually used in mostly in robotic industry, in military domain as well, for radar or any kind of surveillance or any kind of UIR based any kind of surveillance reconnaissance domain also, as well as autonomous driving or ADAS examples, ADAS cases. So, autonomous cars, how it moves and how it senses the environment of the traffic by means of a sensors. So, how the sensors block processing happens inside my GPU or my computer. So, those actually we will be learning here. In robotics also, how the robot sees, what is the robotic vision, and that sense it is through sensor, either through camera or through lidar, sometimes small MMW radar also. So, those data processing, how it is done inside, that we will be talking here. This course also has some direct significance, very direct significance on theoretical postgraduate courses like statistical signal processing, which we have many things will be mostly will be common for the statistical signal processing, plus estimation theory, which is most common for PG, electronics, telecommunication or electrical electronics, this kind of a courses. It has a direct significance of random process and estimation theory, which is a key course in postgraduate control. Many parts of it is a course which we will be covering are actually being covered in a stochastic process, a random process and estimation theory or estimation filtering classes for control system people. And for mechanical people who are doing this robotic navigation or robotic perception, this kind of thing, this course is going to be important enough. The heart of the course is estimation theory. If we know estimation theory and Kalman filters and fundamentals in detail, it will be the kind of main processing thing of the of this course. Apart from that, whatever machine learning algorithms we study, mainly from our different kind of AIML courses, AIML standard AIML courses, that will also, the part of that will also be integrated here. So, the three technologies we will learn: target tracking technology, which is a derivative of estimation theory. We will know how to fuse the data in an optimal fashion from several sensors, from track output of the several sensors, that is called sensor fusion, and from the sensed data or fused data, how we can classify the object, that is your standard AIML classification algorithms. So, all these three we will study in this course. So, I would welcome you. So, and this will be a very practical oriented courses. So, we will be talking several practical examples starting from military domain to civilian domain, like your typical autonomous driving or even for the robotic navigation thing, and there will be lot of problems, small problems, and I hope you will enjoy this course. Thank you very much. Welcome.